go. Today's exercise is about writing function rules. In other words, writing equations from given information. That's what your homework is. Your homework's going to be doing this. Not all of the homework assignments are written like word problems in much detail, but the process is the same. You're going to come up with an equation from the information given. You have to be able to write the equation. Okay? This is as close to real world kind of things as you can get. Okay? Writing, you have information, you have to write an equation, use the equation to solve your problems. This is what you do when you use math in the real world. I will be honest with you though, most of the applications you have in Algebra 1 and even Algebra 2 and some other ones are silly and stupid. That's what you're able to do with the maths involved. You can't do the real heavy lifting until you have more math skills behind you to do real strong applications. My calculus kids have some applications, have some word problems they do that are very, very, very realistic. The ones that you guys do aren't very realistic, but you have to learn how to do the simple ones first before you do the hard ones that they do. It's just, unfortunately, it's a fact of life. A lot of these can be figured out without writing the equation to go with it. Theirs, you can't, but you have to practice it when it's easy. And it does help you see where this might be useful. Okay. So the first one, you can estimate the temperature by counting the number of chirps in the snowy tree cricket. If the outdoor temperature is about 40 degrees Fahrenheit more than 1/4 the number of chirps in 1 minute. Write a function rule for this. And yes, this is real. If you can count time and count the number of chirps from a cricket that they do, the colder it is, the less they chirp. The warmer it is, the faster they chirp. You can actually predict the temperature and get a reasonable estimate. So I need to come up with first thing I need to do is come up with a couple of variables. The two things we're talking about are temperature and chirps. So I would use T for temperature, and we almost always use capital T for temperature. No matter what, it's almost always capital T. T for temperature, temperature C for chirps. Right. Now, if you read the information, it makes it relatively easy. The temperature, T, is equals. The temperature is T equals. Easy enough to do, right? This is where it gets a little harder. About 40 degrees more than 1/4 the number of chirps. To find 1/4 of something, of means times. So I want 1/4 the number of chirps. That means I'm going to have 1/4 times C, and then 40 more than that. What does 40 more mean that I do? I add 40 plus 40. Now you have an equation. Count the number of chirps, divide that by 4 and add 40, and that's about the temperature. And it's actually not that far off. Okay, it's not that far off. It's pretty close. Okay. So let's look at the second. Take a look at the second one. See if you can figure out what you're going to do there. You're actually given one of the variables already. And you'll have to come up with the other variable and come up with the equation to go with it. Okay, so let's take a look at this one. So you're given one of them, M months. The other thing we're comparing it to is waste. And we should use W for waste because it makes sense. So it's write a function rule, how much of waste after so many months. So I want to know how much waste I have after a period of time. So it's the amount of waste equals. And then I have to come up with a rule for that. So I have two numbers I need to consider when making my equation. I have 50,000 tons, and then I have 420. The 50,000 tons is what's already there. The 420 is how much I add per month. Per month. When you hear the words per something, that means multiply. So this would be 420. That's how much I add per month. And then I started with 50,000. Now, if you have, and this is okay, what you start with plus what you're doing per month, that's okay. As long as it's not subtraction, you can put them in any order you want. If it's subtraction, order matters. Not subtraction, any order you want. Okay, 2 plus 3 and 3 plus 2 are the same thing. 2 minus 3 and 3 minus 2 are not the same thing. Subtraction, order matters. Addition, it doesn't. Okay? So either one of these would have been fine. They're essentially the same thing. Okay, this one's a little more complicated. I'm actually going to grab a calculator for this one myself. Read the problem. So, concert revenue. A concert seating plan is shown below. Reserved seating is sold out. Total revenue from ticket sales will be dependent upon the number of general seating sold. Write a function to represent the situation. What is the maximum possible revenue? So, I have two things going on here. It's asking me two questions. First one, come up with an equation that's describing what's going on. Second one is, how much money can I make possible? So I have two equations. I'm trying to find, if I look at this, there's a few keywords I'm looking for. Write a function rule to represent the situation. What is the maximum possible revenue? Revenue is what I'm looking for. How much money am I bringing in? Revenue is how much money you're bringing in. Basic economics. So the revenue is, okay. Now I have two types of seats. I have the reserve seating for 25 bucks a pop and general seating for $10 a pop. But it says that the reserve seating is sold out, which means I've made all the money I can off of that. How much money is that? Well, take how many seats there are, multiply it times 25. I have 10 rows, 12 seats per row. So that's 10 times 12. That tells me how many seats I have. So I have 120 seats, right? 10 rows, 12 seats per row. And then I multiply that times 25. So 120 times 25. So, not that. 120 times 25. So I've already made $3,000 off of the reserved seating. It's already sold out. It's already got $3,000. I hope the band costs less than that, so the rest of it's all for me. So I have $3,000 already. So the rest of it comes from the general seating. How much is it for a general seating ticket? $10. Plus $10 for every general seat I sold. So there's my equation. That's my function rule. That's my equation. Second part is, how much money did I actually make? So I need to take my equation, 3,000 plus 10, and I need to replace G with how many actual seats there are. How many general seats are there? 480. 30 times 16. 480 seats. So my revenue is 10 times 480 is 4,800 plus 3,000 is $7,800. I certainly hope that my act costs considerably less than that so I can actually make some money. That's why they don't sell tickets that cheap anymore. Okay. Question? Yeah, it's important. If you're the band and all of their support personnel costs more than $7,800, you're going to lose money. Not a good idea. Find somebody that's going to cost you less to provide the entertainment. You're not going to hire Van Halen for a stadium like that because you ain't going to make any money. You need a little bit bigger venue or higher prices to be able to do it. That's why some bands cost more, some bands cost less in the same place. Because some cost more and some cost less. Makes sense, right? Basic business. Okay, a nonlinear function rule. This one's a little more complicated. But if you do it step by step, it's not that hard. Okay. Write a function rule of a rectangle whose length is 5 more than its width. What is the area when the width is 5? So I have a rectangle. It's when you have a rectangle, you've got length and width, and area equals length times width. Right? Area is length times width. Whenever I use L, whenever I'm writing L, I don't write it as a standard one. I make it like a cursive L, so it doesn't look like a 1. Right? That is standard. Whenever you use L for length, whenever you're writing a formula, when you handwrite it, it looks like that, so it doesn't look like a 1. You'd hate to get confused. Now, but we can't use length and width because we don't know them, but there is a relationship between the two, right? It says length is 5 more than its width. So its length is 5 more than its width. 5 more means that I do what? I add 5. So that means the length is actually W plus 5. So I go back to my formula and I replace L with W plus 5. So area is W plus 5 times W, because what is my length? My length is 5 more than my width. I only need to know the width to be able to figure it out now. Now, if you gave me that, if this was a test question, and you gave me that, I'd be okay. Later on, we're going to work more with these. It should actually look like distribute the W to get W squared plus 5W. But I'm going to tell you right now, the top one's okay with me. There were 2 parts to this problem. What's the other thing you want me to do? What is the area when the width is 9? So I just take my formula here and put in 9 for W. So my area equals 9 plus 5 times 9. 9 plus 5 is what? 14. So my area is 14 times 9, which would be 90 plus 36, what? 126? 126. Piece of cake, right? Piece of cake. Questions? Okay.